Okay, you should only be watching this video if you've already watched the explanation for number 1 and you've already kind of tried to put something down, even if it's just part A, right? If you haven't done anything for it, then you should really try something and then watch the video to help yourself to like do problems on your own. Okay, so let's see. I'm looking at, right, I am, again, same thing. Estimate the area under the curve for the given interval using Riemann sums and the given number of subintervals of an equal length, okay? Riemann sums just means adding up all the rectangles. Riemann sums are to make rectangles and go. It's the guy, Grigor Riemann, he was the one who really first published this technique for finding area of the curve, so that's what we're doing. Okay, so the length of the interval is 3 minus 0, so that's the length of my interval. I divided by 3 for the number of subintervals, so each subinterval is going to be 1, length of 1. So from 0, right, take my straight edge, right, 0, go up 1, go up 1, go up 1. I have my subinterval of 0 to 1, 1 to 2, and 2 to 3. Okay? Okay. So we're doing LRAM. So if I look at this, what's the left endpoint? The left endpoint is 0. So for this first subinterval, I'll do f of 0. And I plug it in. That gives me 1. I could look at the graph and I could see I got 1 there. Either way. So I'm using this, I'm making the rectangle off of that. And you don't have to draw it in there, I'm just drawing it to kind of go along with what we were doing before. So there's my rectangle. My rectangle has a height of 1, a width of 1. So this has an area of 1. Okay. Next subinterval from 1 to 2. Again, using the left endpoint. Between 1 and 2, 1 is the left. So I plug that into my function to get the height. When I plug it in, I get 3/2. And you can write it as 1.5. It doesn't matter. So the height of this is 1/2. Okay. If you were to estimate from the graph, you would not get full credit for this. You have to make sure you get the correct y value there. So this tells me that the height is 3/2, the width is 1, so the area of that next rectangle is 3/2. For the third subinterval, I'm going between 2 and 3. I'm using the left endpoint, so 2 is the left endpoint. I'll plug that in. So 2 squared is 4. Times 1/2 is 2, plus 1 is 3. I'm getting these values just by plugging into the function. What's the width of it? The width is 1. The area is 3. All these are really nice that the width is 1. The width could be anything we want. It could be 2, it could be 3, it could be 1/2. Right, so it does change, so you want to make sure you're careful to remember that. I add those all together. Let's see, 4 plus 1.5, so that's 5.5. Alright, so if I look at this, here's my left endpoint approximation. You can tell it's definitely an underestimate because all those rectangles are below the curve. Right? Okay, let me do the right endpoint. So same thing. And at this point, if you haven't tried this, pause the video, try it, and then watch the video. Okay. Right Riemann, right rectangular approximation method. Okay, so for the 0 to 1, the right endpoint is 1, so we'll do f of 1. We already figured that out from last time. It was 3/2. The width is 1, so it's 3/2. Okay, so the first rectangle looks like this right here. Okay. Next rectangle. Between 1 and 2, the right endpoint is 2. Okay. So I'm using this to make my rectangle. F of 2 is 3. We figured that out from the previous problem, the previous part. Okay. The next interval between 2 and 3, the right endpoint uses 3. Okay, we're going to have to plug that in, so because we haven't done that one yet. So 3 squared is 9. 9 times 1/2 is 4.5. Plus 1 is 5.5. If we multiply that by 1, so 5.5 is the height. The width is 1, so it's 5.5. Add these together. 1.5 and 5.5 is 7, plus 3 is 10. Okay, so I add all that. This is the sum of all the rectangles. Okay, so we have our left and our right. hey, we have the trapezoid, we can just average those two. Trapezoid approximation is always the average of L and R RAM from what we did before. Okay, 15.5, right? Divided that in half. That's going to be 31/4, right? Otherwise known as 7 3/4. Okay, let me just double checking my work there, because I did a lot of that in my head. 20 halves plus 11 halves is 31 halves. Yep, cut in half is 31/4. Okay, 31, let's see, 7. Yep, okay. Feel good about that answer, so we're good. Okay, let's do MRAM now. For the first subinterval, let's see. The midpoint between 0 and 1 is 1/2, so I'm going to plug in 1/2. Okay, I plug that in, and you can see this one's going to get messy. So 1/2 squared is 1/4, so it's 1 1/8 when it's all said and done. Okay, width is still 1. The length of that. So this is the rectangle right here. Okay, this kind of right here is my rectangle. That has an area of 1 1/8. Okay. Next subinterval, halfway between 1 and 2, is 1 1/2, or 3/2, however you want to think of it. Okay, there's my rectangle right there in purple. Its height, I can find its height by plugging that in. I'm going to use 3/2 when I plug in. 3/2 squared is 9/4, times 1/2 is 9/8. Add 1, and I get 2 1/8. And guys, do it in your calculator. I'm just doing it in my head just to be as quick as I can. Right? 2 1/8, or put the decimal there. Width is 1, so I get my area as 2 1/8. Okay. For this, halfway between 2 and 3 is 2 1/2. I plug that in. Here's where my rectangle is going to be. Okay. Let's see. That's 5/2, right? 5/2 squared is 25/4. I mean, you can see the numbers get a little bit messy, right? And that's why we don't like the fractions. Sometimes they happen when you try us to do MRAM. So, let's see, 25/4 is 25/8. That's 33/8. 33/8 is 3 7/8. Okay, we're going to multiply it by 1, so we get 3 7/8. Okay, so I have all those numbers. Not too pretty numbers. If I add them together, all right, let me do my best. Let's see, I'll add these two together first. That'll give me 6, and that'll give me 7 1/8, right, for myself. So you can see that estimate's a little bit lower than what we had. Let me just make sure I added all those right here. I did add them right, but I just checked my work, and this was 4 1/8. Sorry about that. Okay, 4 1/8 there. All right, so that's actually going to be a little bit higher then. That's going to give me 7 3/8. So I was off by a little bit. Okay. You can see that this estimate, right, in this one, the estimates were the same. That was because this was linear. It was the same, but when it was curved, these aren't going to be the same. And if somebody said which one's better, it's hard to tell which one's better. It just depends on the problem at hand, right? You can see that in this one, neither one's better. They're equal, and they're both actually 100% accurate. On this one, it's you can't really tell which one's better. You know, it's kind of like, you'd have to explain which one you think is better. Personally, I think the MRAM is better, and the reason I think it's better, if you made me make a choice, that if I did trapezoids, if I turned these to trapezoids, that would make straight lines through these. Okay. All right, that's what the trapezoids would look like. And I don't know if you saw the straight lines. They're actually always above there, so this seems a little bit of an overestimate because the way the curves there. But I'm not going to ask you this. I'm just telling you, like, here's how I would. So in this one, MRAM is actually better. But there are some that the trapezoids are going to be, approximation is going to be better. Okay. So hopefully I explained that well enough for you, and that makes sense, those two examples. Right now, you try these. I'm going to post the answers online, and if you have questions, you just email me and let me know. There's also going to be some additional book problems as well. So do the best you can on it. Email me. Keep emailing me your questions. You can and let me know what I can do to help you out.